Hello class, today we're going to go over how to conduct a hypothesis test of a claim about population mean. To do that, we're going to look in section 8.3 at number 2. Let me read that for you. A group of students estimated the length of 1 minute without reference to a watch or clock, and the times in seconds are listed below. Use a 0.05 significance level to test the claim that these times are from a population with a mean equal to 60 seconds. Does it appear that students are reasonably good at estimating 1 minute? Here's your numbers. Now let's go ahead and write down our hypotheses. Our two hypotheses. So we have the null, which is h naught. Let me fix that h real quick. So as I was saying, we have the null, which is h naught. That's that little 0 down there. And we have the alternative, which is h with that little 1 beside it. Now the null always has an equal sign with there. So we're going to say that for our null, that mu is equal to 60, and our alternative would be mu does not equal 60, because we're trying to see if there's a difference, if they're actually close to that minute mark. With the hypothesis test out of the way, next our test statistic. To start off with the test statistic, we need a formula for it. That formula would be T equals x bar minus mu sub x bar all over S divided by square root of n. Now let's go ahead and find all these values. To do this, we can use the calculator function. You can use YouTube, Google. There's all different ways you can find this out, but you can use your calculator to find x bar and standard deviation. If you cannot find it with YouTube or Google, please either contact me through course messaging or feel free to post on the discussion board on Blackboard. Let's go ahead and make it a little neater for you. And whenever I plug these numbers into my calculator, I find that x bar is equal to 60.8. My S, that sample standard deviation, is approximately 17.2469. Now that we have these values, let's go ahead and move on to find n, which is 15, and we can go back and plug this into our formula. X bar is 60.8. The mu we get from the hypothesis. We look at the null hypothesis, mu was 60. Standard deviation was 17.2469, and n was 15. We can plug this into the calculator. Make sure you know your calculator would have put parentheses, and we get approximately 0.18. Now that we have the test statistic, it's time to move on to the p-value. Ignore that. Now, since this is a t-test, we will need a degrees of freedom. So we're going to find p-value with degrees of freedom, that's the df I just wrote, is equal to 15 minus 1. Our formula for that, in case you forgot, was n minus 1, and n was 15. Now look at our table, and we see that our p-value falls between 0.1 and 1. To find that, we looked at this we looked for 0.18 in the row with 14 degrees of freedom. Now, since this is a two-tailed test, I'm going to multiply that 0.1 by 2. Notice I just multiplied the 0.1 and not the actual whole number 1 because our probability cannot be more than 1. By doing that, we find out that our p-value is between 0.2 and 1. Now that we have our p-value, we can move on to our conclusion. Now with our p-value, we might not know the exact value of it, but we don't need it. We know it's somewhere between 0.2 and 1, which means it must obviously be what? Well, if it's between 0.2 and 0.1, it has to be greater than 0.05, which is alpha. And if p-value is greater than alpha, then we will fail to reject H0. If you have any questions about how we read the p-table, where these values came from, how to plug into a calculator, please feel free to message me through course messaging, ask your classmate through course messaging, or you can post in that discussion forum on Blackboard. I'll see you next time.